Carbohydrate in food. In this lecture, we will cover the usage of fiber and modified starch in food industry. Hydrocolloids are a group of long polymer that consists of polysaccharides or protein. They are suspension of particles in water where the particles are molecules that bind to water and to one another. Due to the presence of large number of hydroxyl group, their affinity to bind to water molecules increases. They are incorporated into food formulation mainly to control rheology and provide structure as well as improve shelf life. They are required in low concentrations to confer the desired effect to the food microstructure. In aqueous environments, they swell, increasing their hydrodynamic volume, and thereby increasing the viscosity of the system. Hydrocolloids are used as thickening agents, gelling agents, and they're also applied for inhibiting ice and sugar crystal formation in ice cream and the control release of flavors. Since you know that hydrocolloids are fiber, so they can actually slower the release of flavors since they are slowly digestible by our body. Another example is also being used in medicines. Whenever a drug and active compounds and drug needs to be released slowly, so they also use certain kind of hydrochloride. Tables 1 shows the hydrocolloids and sources, and then the typical amount that is being used in a food system and the texture, functionality, and typical application and the documented health benefit. We have hydrocolloids from tree exudates such as Arabic or acacia gum, and then from seeds, we have locust bean gum and tara gum. From plants, we have pectin, cellulose derivatives, and konjac. From seaweed, we have agar alginate and carrageenan, and from microorganisms, we have gellan gum and xanthan gum. The next usage of fiber in food industry is as prebiotics. In our digestive system, the extent of polysaccharide cleavage depends on the abundance of the particular microorganisms producing the specific enzymes required. Substrates that reach the large intestine undigested and are metabolized by the microflora of the colon represent a special class of dietary fiber referred to as prebiotics. Prebiotics are substances that are not digested by human small intestinal enzymes but provide favorable physiological effects and health benefits to the host by selectively stimulating the growth or bioactivity of beneficial microorganisms already present in the gastrointestinal tract, especially in the large intestine, colon. Inulin and fructooligosaccharides, FOS, derived from inulin, are popular ingredients used to add dietary fiber to food products. Another usage of fiber is resistant starch. Some of the starch in a food may exist in a form that allows it to pass through the small intestine intact, that is, undigested. RS is an especially important component of dietary fiber because it produces greater amounts of butyric acid than do other forms of fiber as it undergoes fermentation in the colon. Butyric acid is implicated in the prevention of colorectal cancer. As mentioned in the previous slide, resistant starch is an important component of dietary fiber. What is dietary fiber? It is the indigestible portion of the diet, i.e., resistant to hydrolysis by human digestive enzymes. Starch, once gelatinized, is the only polysaccharide that can be hydrolyzed by human enzymes. It is broken down to D-glucose, which is absorbed by microvilli of the small intestine to supply the principal metabolic energy of humans. Only when complete digestive hydrolysis to monosaccharides occurs are the products of carbohydrate digestion able to be absorbed and catabolized. Carbohydrates not digested to monosaccharides by human enzymes in the small intestine such as maltodextrins made from starch pass into the colon or large intestine as dietary fiber. When undigested polysaccharides reach the large intestine, they come into contact with normal intestinal microorganisms, some of which produce enzymes that catalyze hydrolysis of certain polysaccharides or certain parts of polysaccharide molecules. The consequence of this is that polysaccharides not cleaved in the upper intestinal tract may be broken down and utilized by bacteria within the large intestine. Sugars that are removed from polysaccharide chains are used by the microorganisms of the large intestine as energy sources in anaerobic fermentation pathways that produce lactic, acetic, propionic, butyric, and valeric acids. These short-chain acids can be partially absorbed through the human intestinal wall and metabolized, primarily in the liver, for energy. In addition, a small, though significant in some cases, fraction of the released sugars can be taken up by the intestinal wall and transported to the portal bloodstream where they are conveyed to the liver and metabolized. It is calculated that, on average, about 7% of human energy is derived from sugars split from polysaccharides by microorganisms in the large intestine or from the short-chain acids produced from them via anaerobic fermentation pathways. Nutritionists set requirements for dietary fiber at 25-50 grams per day. Dietary fiber largely consists of hydrophilic molecules that increase intestinal and fecal bulk primarily by means of its water-holding capacity, which lowers intestinal transit time and prevents constipation. Soluble fiber lowers blood cholesterol levels, perhaps by sweeping out bile salts and reducing their chances for reabsorption from the large intestine, lessening the chance of heart disease. Table 2 shows the food source of dietary fiber. That consists of insoluble fiber and soluble fiber. You can try to relate again to our previous lecture on the sources of polysaccharides. Table 1 shows the functional properties and main source of dietary fiber. You can see that the solubility of soluble starch is high while insoluble starch is low. Moving on to the next subtopic, usage of modified starch in food. Remember our previous lecture on starch. There are several disadvantages of native starch: inconsistent viscosity and solubility, susceptibility to shear, reduction in viscosity upon stirring, susceptibility to acid, degradation upon storage by acid hydrolysis, irreversible insolubilization of starch paste with formation of a precipitate or gel that we called setback. Beyond setback, if the gel is left standing for a longer period, the process continues with occluded water molecules being expressed from the gel to leave rubbery solid surrounded by the expressed water. So why modify starch? Of course, because we want to encounter the disadvantages of the native starch as previously mentioned. So, starch modification are mainly to modify cooking characteristics, to improve tolerance to rigorous processing condition, to decrease retrogradation, to increase freeze-thaw stability of paste, to decrease paste, gel syneresis, to improve paste, gel clarity, to improve film formation, to improve adhesion, and to add hydrophobic groups for emulsion stabilization. Modified starch is used in food in several ways. By making a product easier to dissolve in cold water or milk for instant gelatinized recipe, binding ingredients together and acting as thickener for soups, helping powdered foods such as powdered cheese sauce and gravy to have a less lumpy consistency when mixed, serving as fat substitute for low-fat food, acting as emulsifier and stabilizer for salad dressing to keep oils from separating, forming a hard shell on some candies like jelly beans, and producing food with longer shelf life. In food industry, starch modification is done through several techniques. We have physical modification where the changes in morphology and 3D structure of starch under the influence of some physical factors such as moisture, temperature, pressure, pH, radiation, pulse electric field, ultrasonic wave. Chemical modification where the alteration of physicochemical properties of starch by introducing new chemical or functional groups in starch through cross-linking, conversion, and substitution without physical alteration in shape, size. Enzymatic modification are starch hydrolysis products where the changes is carried out using enzymes. Examples of physical modified starch are pre-gelatinized starch, starch paste heated in a drum dryer where granules almost instantaneously gelatinized and pasted, and the paste is dried into powder. It mainly applied in instant soup and instant pizza. Second example is cold water soluble, swelling starch. Starch corn is heated in 70 to 90% ethanol. Swell extensively in cold water and disperse in sugar solution, pour in mold and you get gum candy. Third example is resistant starch. It forms a highly crystalline starch by repeat freezing and thawing of high amylose starch. Non-crystalline region will be removed by enzyme and the rest is resistant starch which can be used as dietary fiber. It also can be used as food ingredients in cake, biscuit, and cereal. Second technique is chemical modification. The examples of chemical modified starch are cross-linked starches, which introduce bonds. Examples as phosphate in the granules at random locations between chains of glucose reinforcing hydrogen bonding and inhibiting granule swell. We cross-link to control texture and to provide heat, acid, and shear tolerance. Cross-linked starch is used in heated and sheared products such as sauces. Next example is stabilized starches. Ionic groups are scattered throughout the granules to block molecular association through ionic repulsion as well as steric hindrance. This modification prevents gelling and weeping or syneresis and maintains textural appearance. It is used in frozen products such as frozen chicken pies. Another technique is enzyme modification. The use of alpha amylase, an endogenous enzyme, cleaves the glycosidic bond within starch in non-crystalline region, which produces dextrin, maltose, and maltotriose. The use of beta amylase, an exoenzyme that hydrolyzes starch at non-reducing end, produces maltose. The use of amyloglucosidase, an exoenzyme that hydrolyzes starch at non-reducing end, produces D-glucose. Another example is the use of isomylase and pullulanases corn syrup. Coming to the end of the topic, the students are expected to understand different usage of fiber and modified starch in food industry. Here are the references. Thank you.